My amplitude is 1/2. My period is 2 pi over 2. Okay, which is pi. This is from yesterday. Remember, the period for sine and cosine is 2 pi over b. Okay? And then I'm going to find my intervals just for Jenny. Jenny, how do we get my intervals? I take my period and I divide it by 4. I'm going to find the 4 sections that are part of my cosine graph. So, the first one would be pi over 4. If I double that, what's pi over 4 times 2? Pi over 2. You got to know your fractions. Let's say I write it over here. Pi over 4 times 2. How does that reduce? It reduces to pi over 2, doesn't it? Then if I do pi over 4 times 3, what do I get? 3 pi over 4. And then I know my last one is pi because I already determined my period to be pi. So I'm going to mark those off on my graph here. Pi over 4, pi over 2, 3 pi over 4, and pi. So from here to here is my period, just like yesterday. Okay, now I have to think about from my baseline, my amplitude is 1/2 above and 1/2 below. So from here, I'm just going to kind of mark it right here and right here. And if I think of my y-axis as this being -1, where is this then? This is -1.5, correct? Yes? Isn't the what? No, because it was a shift down of 2. No, you start your graph at 1, but your baseline is always at the x-axis. This is a shift of the baseline. Do you know what I mean by that? It's right there, you guys. You can come in and get it. If you think of yesterday's cosine graph, Jason, the baseline was here at the x-axis, and then we started our graph up at 1. So the shifting moves the baseline. Good question. Okay, the shifting moves the baseline. So my amplitude comes off the baseline. So it's going to be up 1/2 and down 1/2. So this would be -2.5. Not that you really need that, but just as a visual. And so now I start my cosine graph at the peak here, which is this spot right here. And then this is going to be the first interval, then the next interval, then the next interval, and there we go. Right here. It's 1/2 off the baseline, and this shifts the baseline up and down. Okay? And then you connect them, and there's your cosine graph. Now, the graphs go forever because you're really going around the unit circle, aren't you? And you can keep going forever around unit circle both ways. So that's why you can just kind of then sketch another part of this. It goes forever. And you should put an arrow on the end of your graphs. So, absorb that. We'll do some more. How do you feel about that? Remember, K shifts the baseline, and your amplitude comes off the baseline. Let's do another one. All right, this is a sine graph. What's my A? That's my A. My amplitude is 2. This is my B. What's happening inside of the parentheses? Which way is my graph shifting? To the right 4 pi. So my period, original period, is shifting to the right 4 pi. Okay? So I'm going to write that down. My B is 1/2. I shift to the right 4 pi. So this is just kind of what's happening in my equation. So let's determine our period. Period is equal to 2 pi over b, and that's 2 pi over what? 1/2. That's my b. And then I flip the denominator and just multiply. So I get 2 pi times 2. So my period is 4 pi. There is no vertical shift on this one. So my baseline stays where? Where's my baseline stay? At the x-axis, right? 0. Okay, so if I was not shifting, I would have 1, 2, 3, 4, correct? Right here. If I wasn't shifting, my period would be here, correct? But now I'm shifting, and you're going to say, well, it doesn't really make a difference to the graph, and it doesn't, but to identify the period, we're going to shift over here too, 4 to the right. My original thing would be right here, and now I'm going to go over here. So let's draw the original one first. Let's do our intervals. How do I find the intervals again? 4 pi divided by 4, so I have intervals of pi. And that's where I came up with these numbers. Pi, 2 pi, 3 pi. If this was an original sine graph without a shift, remember my amplitude is 2, I would start where? I would start here if it was an original one, right? And I go up to here, down to here, down to here, and then up to here. And I'm just going to do that with a dashed line. That is before the shift to the right. But now I have a shift to the right, so it's actually going to look the same, but we're going to identify it as having shifted to the right here. So I'm starting here, and I go up to here, down to here, and then that's it. So it's like this. Oh no, I missed one. Oh, I screwed up on that. Can you forgive me? What did I do? Does anybody know? I didn't do the middle one. Right, this should be here, and this should be here. So I kind of screwed up on that. Up, down, and up. Sorry. Yes, Claire. Pardon me? What does the B do? It helps you determine your period. Because you have to do 2 pi divided by B to get your period. And that does not stretch, no. Okay. Now, ladies and gentlemen, you've got to put arrows because they do keep going in both directions. You can go forever with the sign in both directions. So it's not too bad. That's a shift to the right. It's not really a big deal. Okay, turn the page. 2 more and then we're done. All right, so ladies and gentlemen, look at this one here. We have y equals, I'm going to put a -1 there. There's a negative. Cosine 4x plus 1. Okay? This is my A. This is my B. What does this do? Up 1. So I'm going to go ahead and change my baseline right away on my graph. It shifts from the x-axis up 1. So right here, shifts the baseline. Okay? Now the amplitude is always going to be the absolute value of A. I didn't really point that out yesterday, but it's always the absolute value of A, which means our amplitude would actually be what number? 1. Our amplitude is 1, so we're going to go up 1 from our baseline and down 1 from our baseline. Our period is 2 pi over b, which is 4. So what is our period? Pi over 2. Okay. Is there a shift like this, left and right? No left and right shift. I'm just identifying everything that I can here. No left-right shift in this graph. And we already did the vertical shift. Okay. Let's find our intervals. So our period is pi over 2, and I got to divide that by 4. You don't necessarily need to do this math. We could just jump right in and mark 1, 2, 3, 4 over as pi over 2. Can we cut that in half? What's half of 1/2? 1/4, so halfway between there would be pi over 4. You can do it this way, or you can write it out this way. It doesn't make a difference. What's half of 1/4? So this would be pi over 8. Now the only tricky thing about this is you have to realize, okay, I got to go 3 over. So what's 3 of these going to be as a fraction? 3 pi over 8. Okay. And you would get that same thing if you divided by 4 and wrote it out like we did before. So there's our period. There was no left or right shifting. Okay, now it's a cosine graph, so where's it going to start? At the top, the peak, or at our baseline? So it's cosine starts where? It starts at our peak up here. Cosine's like a sideways C, remember? So it starts up here, then it's going to go to our first interval, then down, then up, and then up again. And then you kind of sketch it. And then remember, it's going to keep going. So you should always sketch a second part of it, at least, if there's room. Okay? Let's do tangent, because I know you've been waiting for tangent. Almost done. All right, tangent. Is there really an amplitude in tangent? No, because they just keep going up and down, right? But this number really does what for it? It really makes it a stretch and a what we haven't seen yet. It's going to make it do what? Flip. Because our original tangent, if you remember, went up from left to right. When there's a negative, it's going to go down from left to right. Okay? So here we have an A of -2. It's not really an amplitude, it's a stretch and a flip. Means stretch and flip. Two, the period. Remember, for tangent, what is our period for tangent? Pi over what? B. It's actually the absolute value of B. But what is our B in this equation? Right, our B is equal to 1 in this equation. So our period is pi over 1, which is pi. What does this do for us? It's in the parentheses, it's H, so what does it do? And this is still a minus, so that means that had to be a plus, or positive, which means it shifts it to the right, pi over 2. So we have a shift right of pi over 2. Okay, the period helps you determine your asymptotes, correct? You have to remember in the original tangent graph, where were our asymptotes? Pi over 2 and negative pi over 2. Because that's where tangent is undefined, correct? On the unit circle. All right, so if we're going to shift to the right pi over 2, where is pi over 2? It's right here, correct? This is where our original asymptotes were, right? Before we did any shifting, correct? Are you with me on that? You have to remember that. To remember, our original asymptotes on the unit circle are pi over 2 and negative pi over 2. That's where it starts. Yes? Because that's where it's undefined. I don't believe your faces. Are you good with me on that? This was the original basic tangent function on the unit circle. Pi over 2 and negative pi over 2. If you think about the unit circle, that's where tangent is undefined. That's why there's asymptotes there. Okay? If we take this graph and shift it to the right pi over 2, where is this asymptote going to end up? At pi. Where is this asymptote going to end up? At 0. And that's what we're doing for this one. Shifting to the right pi over 2. So our asymptote ends up at pi and 0. Pardon me? Well, I'm not there yet. On the what? For a tangent graph? Oh, you don't understand this? Well, this is where y is 0. This is where it's x is pi over 4, x is pi over 2. This is 3 pi over 4, and that's pi. So this whole distance right here is pi. And this is the y-axis, and this is the x-axis. So this is at x is 0, and this is at x is pi here. It's spread out, this particular graph. So this is my period. These two lines are where that graph cannot hit. And then you just put a dot in the middle. And normally we would go up from left to right, but this time we have to do what? We got to go down because of the negative. And we kind of just sketch it, and this is all you have to do, just sketch it, cutting through that middle thing, and down like that. Now, there is a formula to find the asymptotes, if some of you prefer that instead of just thinking about it. To find the asymptotes, you do pi over 2 times the absolute value of b. But it's kind of the same thing I was talking to you about. What is our b in this equation? 1. So our asymptotes are actually at pi over 2, like they were in the original tangent graph, but because of the shift to the right from the parent function, y equals tangent x, we have to move pi over 2 to pi. That's basically what I was telling you earlier. I'm just writing it out. The shift from the parent function would start at pi over 2, and we have to shift it to the right, pi over 2. That's how it ends up at pi and 0.